Okay, we are recording. So the first step that we want to do is UseVar. Somebody said, was that, who said that? Daniel? Somebody said UseVar. Anthony? All right. So Anthony's on top of it. Sex, age were the two covariates that we're going to add in there. We also have race, but some of you. Oh, thank you. UseVar R. Some of you put race in as a covariate, some of you did not, and some of you I emailed and said don't use race as a covariate. Why don't we use race as a covariate? It is a categorical variable, right? It's labeled as 0, 1, 2, 3, 4, 5, 6 or something like that. And so even that assumes that there's some kind of linear rhyme or reason to race, and there isn't, right? Like if you want to include race as a covariate, it's fine, you can do that. How do you include race as a covariate in a model like this? What would you do? What's that? Yeah, you could dummy code all race, right? So that it makes some group the always zero group, right? And then for each other race. So does anyone recall how many categories are actually in race here?
0 through 3. So
it's okay. So there's 4 categories.
No,
how many?
No, wait, no, 7. 0, 1 through 7.
1 through 7.
Yeah.
Okay, so if it's 1 through 7, that means that there are 7 categories. How many dummy coded variables would you have for 7 categories? 6. You would have 6. N minus 1, right? You have one group that's set as your base group. It would be a lot. It would be ridiculous, but it's N minus 1. In M plus, you can also specify that as a categorical variable. But if you specify it as a categorical variable, M plus is going to default to it being an ordered probit variable, which means that there's, again, some sort of rhyme or reason to moving up to each category, and there's not. So the best approach here would be to not include race as a covariate, especially considering 96% of the sample I think is like white, right? The other approach would be to say, to dummy code 6 dummy coded variables, right?
I have a question here. So if we include those variables in use variables, but we do not include them in the model, like when we in the model code,
Yeah.
they're still fine, right?
This is a good question. No. Let's talk about this for a second because several of you did this as well. You had stuff listed in UseVar that was not listed in model. If you do that, M plus is going to estimate variance. It's going to say that it is either uncorrelated with all other variables in the model or something along those lines. You'll get some sort of a warning message. And if you have something in there that is completely uncorrelated with everything and it's estimating a variance, uncorrelated means you don't have any predictors on it, it is going to give you terrible model fit, right? Model fit is based on the differences, the squared residuals based off of relationships. And if you have anything in there that's not linked to something else, you're going to have huge squared residuals, right? Yes, so you'll get really bad model fit. If you have really bad model fit, that's the first thing to think of, like, do I have something in UseVar that I'm not using? You can find that by scrolling down and looking at variances, and you will see something that is 100% residual variance. And if you have 100% residual variance on any variable, that's going to give you really, really bad model fit, right? That's going to be a problem. So only put stuff in UseVar that is also in model. Also, some of you put, so for example, we have BIS-BAS, we have C underscore BIS-BAS, and then several of you use the define to create CBIS and CBAS, right? And then you put them all in UseVars. But you only included CBIS and CBAS in your model. Consequently, you have 4 other variables that are perfectly correlated with other variables in your model that you haven't specified. That's going to give you really bad model fit as well, right? Those are some things to kind of think about. Back to what we were doing here, we've specified our 2 variables. What else do we need to have in UseVar here?
The variables we're going to define.
Okay, so we're missing something. We're missing a statement here, right? We need to define. And what are we going to define? Okay, CBIS. And why are we going to define that? We've already got CBIS. And what are we going to define this as? Why are we defining this when we've already got it? Thank you. Yep, makes it easier to probe simple slopes and to form that interaction, to be perfectly honest, right? Okay, Seabass. Kick his ass, Seabass. Oh, that's on the recording now. Anybody know what movie that's from? Come on. I'm that old?
Don't you only probe interactions for like the moderator?
Yeah,
So why would we?
because you have to form that interaction.
Huh?
Because we will have to form that interaction. I mean, so theoretically, you could, what you're asking then, right, is can we do this? This by Cbass equals Cbass times C underscore BIS, right? That's what you're asking. Yeah, you could do that. I do it this way, and then you wouldn't have to define BIS. You can always just use that. I only do it this way because it's the way that I like to. Like, that's just my preference. But you're absolutely right. You don't need to do it that way. You don't need. Yeah, go ahead, Colleen.
Why do you need to redefine it so that you can do the simple slopes? Like, why can't you do the simple slopes without redefining it?
How would you do it? I can tell you there is a way to do that with something called loop in M+. It's more complicated, and so I'm just teaching you guys a simple workaround for this. But to your point, how would you add one standard deviation and subtract one standard deviation if we didn't use define?
Just do it on the variable.
Where?
Like, see this minus standard deviation.
Like right up here or here?
What?
Yeah, I'm not quite sure what you're asking.
Are you asking why do you define C underscore bis to C bis?
I mean, I did my simple slopes and I didn't redefine it.
You didn't.
No.
How did you create them?
I just used
Walk
the
me
I just used the normal ones.
walk me through what you did here.
Hmm?
Walk me through what you, the normal ones, because these.
No, I just used the C underscore this and C underscore bass, and then I ran it, and then looked at the interaction, and then I went back, and I created a new variable for high, and then just subtracted that from C underscore this.
You created a new variable for high and define, right?
Yeah, so that was the part that would be equivalent to this.
Yeah, and so that's what we're going to do. I'm just getting this set up right now. You don't have to do it in this step, right? We're just testing the model, but eventually, you're right. We're going to have to go back and create a new variable, and that's going to get to your point. We'll work through this, and when we get to the end, if it doesn't make sense, then let's come back to this question.
Wait, okay, so what I did was, I guess, I have all those variables you have, but I also have high bis and low bis. But instead of having that, you'll just like put that value in the capital C bis, right?
Sure.
Is
I
that
mean,
like the same thing?
yeah. So what you're saying is you did something like this, and then you also did H. It should be Bass, right? What is
So yeah, it was,
what is the standard deviation here? I don't recall. Okay, so minus 0.8.
well, instead of C bass uppercase, it would just be the original C underscore.
Okay, you could do that as well.
'Cause
Right.
I didn't define I didn't do the first two steps either.
Yeah, you could do this as well. This is what you're saying that you did?
Yeah, like minus the top.
And then you used this to make this interaction?
Yeah.
Okay, I mean, that works as well. You could do that as well.
Okay.
There's nothing wrong with that. Yeah. This gets to the point that I was saying earlier, which is there are a number of different ways that this can be done, right? I just want to make sure that you, like, the most important piece is not that you follow exactly what I'm doing, but that you understand what you're doing and that what you're doing gets the result that you want it to get. If you did it this way, Colleen, that works. I mean, yeah, there's nothing wrong with that. I like to do it this way only because that's the way that I do it, right? And if you do it a different way, that's awesome as long as you get the right result. And in fact, it's maybe better. Yeah, no, it's maybe better if you do it a little bit differently and get the result that you're supposed to get because it shows some comprehension, right? That you're thinking about this and you're able to. I remember a moment when I was an undergrad in stats class, and the professor showing us something, and I can't remember exactly what it was. And I said, wouldn't it be easier if you just did blah 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 blah? And she was like, yeah, but you're skipping this step. And I was like, but you get the same result, and it makes more sense to me if I do it that way. And she was very kind of concrete that I should not be doing it the way that I was saying. But I felt like by doing that, you're showing like, oh, I understand this, and I can do it in a way that's simpler for me, or that makes more sense to me, right? And so that's great if that's how you approached it. Fantastic. Okay, so back to this. We're going to put in use vars here, CBIS, CBAS, and then CBIS by CBAS. What else?
ALS.
We need ALS in here. Can it go there?
Right?
What's that?
For the font.
Thank you.
Quick question while you're doing that.
Yeah.
I know you said that we didn't include race because it's a categorical variable. Isn't sex a categorical variable?
It is a categorical variable.
But it only has 2 categories.
Perfect, which means the dummy code is 1, right? And so sex can be included as a categorical variable, not a big deal. You could completely drop it if you wanted, but it doesn't indicate any like higher or lower. In fact, when you get a code, we'll look at sex when we do this, because I think that there's some interesting things that happen. All right, what's the last thing that needs to be included in here? Anxiety. And is that it? All right. I need to find my. I hate that my screen gets really, really kind of cramped on my computer when I'm recording. Oh, you locking up on me? Hey, you. There we go. All right. What's next?
Analysis.
Perfect. And
Estimator equals
And with M plus, you can actually say, like, we put equals here, we have R up here. You can put R or is or equals. They all mean the exact same thing, and it does not matter if it's singular or plural. So just FYI. So this could say estimator is MLR, and I'm pretty sure you can say estimator are MLR, and M plus will assume it means the same thing. What's next? Model. Good. All right. What is our model? So I would recommend before you specify anything in M plus, you draw your model out, right? And this is especially crucial when it comes to doing power. We're going to talk about this with power today. But so I would draw the model. Oh my God. Oh, here we go. I would draw the model out. And so what is our model here? Like if we're working this way, we're working this flow of a path model. What goes on this side?
BIS.
Okay, so we have BIS.
All the way on the branch, you put ALS.
Okay, all the way.
Wait,
on-
are we doing the with anxiety?
Yeah, yeah,
Alright,
the
then
whole
you
model.
Put anxiety on that.
Put anxiety over here. Okay.
ALS in the middle.
ALS in the middle. We are really just jumping around.
Kinda terrible. Then you put an arrow from BIS to ALS,
Okay, that's true.
and you put a BAS box somewhere there, and then an arrow to the arrow.
An arrow to the arrow. That is also true. Or that's one way of doing it.
And you connect the rest of the triangle.
We're missing something here. Connect the rest of the triangle, which is what?
ALS to anxiety.
Okay, ALS to anxiety. We're still missing
And then you have BIS to anxiety.
VIS to anxiety.
Do you have to put an interaction on the model too?
Thank you. Yeah, we do have to put like this interaction here is also incomplete, right? Because what's one of the requirements for an interaction?
BAS to ALS.
We have to have that lower order, right? And then we also had what?
Main effect of PA.
Main effect here. What else? There's one other thing that's included in this model that's really hard to see when you draw a model this way. What is that thing?
Main effect of interaction variable
On,
on anxiety.
yeah. So the main effect of the interaction variable on anxiety. When we draw this path, and this is the way that we draw the path, right? That's fine. Like if you were to put this in a paper, this is how I would do it. But when you're drawing, when you're sketching these out, this makes us forget that really in M plus is thinking about this as a variable, right? It just assumes that that's another variable. So we have that, and we also need to have then this, right? So go ahead. Somebody,
So in our homework, what exactly would you like us to do with respect?
we're gonna get there. Yeah, we'll get there. So,
Because I don't think I did.
You're not supposed to report that, right?
right.
How do you get that from the information we were given? Like that model from the summary that you gave?
So this isn't actually the model that I asked you to run, right? Like this is a fully saturated model right here. The model that I asked you to run didn't include this path or this path, right? And so part of what I want to do, and this is the way that I always operate with homework, is I want to see the way that you're thinking about something, right? And so adding those in becomes important because it's like, oh, actually this path, or this path were not included. I just want to see that you are thinking about how do I get the direct effects here? How do I get the total direct effect, or the total effects? How do I get the indirect effects? Are these paths needed? He didn't put them in, so it makes me feel like I don't need to include those. But if I don't, something happens, right? What happens if you don't include those? You lose
More
something.
degrees of freedom. So
You do get more degrees of freedom.
so there will be a bad model that might be because the degrees of freedom will be less.
So actually, if we run this model right here, we get zero model fit, right? Because it's fully saturated. We're specifying every possible path that we can, so we get nothing. Like we'll see a bunch of parameters, but we won't get any type of model fit. Let's walk through that to start with, and then we'll backtrack the logic from there of what should be trimmed or removed from the model based on the information that I gave you, right? So,
Question about like
Shoot.
model fit. 'Cause, like I'm just new to M plus, and so like if I were to run this like SPSS, I wouldn't get model fit.
You're right.
Why am I getting them here? Is it just like what is this? I'm just,
what is model fit?
like I know what model fit is, but I'm just like used to seeing that when I'm doing like CFA or an SEM, but like we're not doing either of those. So why
I
am
mean, so technically this is SEM, right? it's-
this is being treated as a path analysis.
Yeah, yep.
Okay.
Yep, it is a path analysis, and you can think of almost everything in M+. As long as there's a mediator, M+ is going to treat it as a path analysis,
Okay.
as a
But
structural
in
equation model.
process, it's not really treating it as path analysis.
Right, process doesn't, and process doesn't give you fit statistics, right? You get R squared and you get stuff like that.
Right.
And in SPSS, correct me if I'm wrong, you used to be able to do structural equation modeling in SPSS. Can you not do that anymore? What was it? Was it Amos? Amos was a package within SPSS, right? But I also hate Amos. So, just as a heads up, I'm going to be at a conference next week, so I won't be here. I will post a lecture, like a full-on lecture on factor analysis with examples, like I will work through factor analysis, and then you will have homework, and so it will be very much like a class session, and we will use SPSS for that. Ugh. But we're gonna do factor analysis in SPSS for starters, because that's the way that factor analysis was done for years and years and years. And then the following week, when I get back, we are going to do factor analysis in M+ using latent variable modeling, structural equation modeling, both exploratory and confirmatory factor analysis. With M+, of course, you'll get model fit. You'll see fit indices. In SPSS, you do not see fit indices. You get eigenvalues. And we're going to look at things like the knee of the scree and these things that nobody looks at anymore, right? But that's the way that I was taught to do factor analysis. And I think that there's some value in understanding that. If for no other reason, then you still see it in papers, and so I suppose you should understand factor analysis from. And to be honest, it also speaks to kind of model coherency. So, all right, back to what we're talking about here. Let's specify this model. What's the first thing that I type here?
ALS on and CBIS. CBAS, the interaction. I guess you would put a control variable in there too.
Sure, why not? Next, I'm going to show you guys actually something here. We didn't talk about this last week, but you can also put anxiety in that statement right there, right? And that actually takes care of all of the paths up to here and all of the paths up to here, and we're just missing one statement now. What's that one statement?
Anxiety on ALS.
And your model is specified. That is it.
So like, when I did the homework, I did just the first part first. Like I basically just did the moderation, and then I did the conditional interact.
Okay.
What you wanted, or did you just want us to run them?
Yes, so the idea is to run the whole thing at once, right? And I'm going to walk through why we're going to run the whole thing at once. But if you break them into separate parts, you get roughly the same answers, right? But you don't get indirect effects when you break that into separate parts, and you certainly don't get conditional indirect effects, right?
Well, I was saying I did the moderation, and then I did the whole thing.
Oh, okay.
Because
I mean-
you kind of wrote it like as if it was two different things. So I was
Fair
like,
enough.
okay, should I do two different things?
Fair enough. I mean, I suppose if you follow the letter of what I wrote, then sure, that works. I would say whenever possible, your best bet is to test your full model and run with that full model in that case. And so in this case, going with the full model is and again, like I said, I expect that you guys are going to wonder a little bit about what I'm looking for. And so one of the things that I'm always looking for is do your full model and then work off of that full model. It's not uncommon in papers to see people start with, we just did the moderation analysis and then we did this other thing and then we included that in there, right? I think it's just better science to do everything at once. Because it's quite possible that you do your moderation analysis and then you put everything in the full model, and because of multicollinearity between your outcome and your mediator or something like that, that interaction is no longer statistically significant, right? So you go through the process of testing this interaction and probing this interaction, only to find out that when you run your full model, it doesn't matter. Make sense? Okay, what's the last thing we need to add here? Okay, and what do we want to put for output?
STDYS.
Anything else?
Mod 3.8.
I like to put mod. You don't have to put it, but all right, are we all good there?
Wait, I have a question.
Shoot.
Can you explain why in the first line of the model it's ALS anxiety on the rest of them?
Yeah, because these three variables plus our covariates are predicting all of this, predicting this, right? Now, technically, I did not ask you to do this, right? Technically, in the homework, I said that ALS mediates this relationship. And so you could delete that and run this model like this, in which case these paths are not there, right?
In the new break, you asked that you to estimate conditional direct and indirect.
Okay, gotcha. Maybe I did ask you to do that. Regardless, we're going to do it like this for right now.
So like,
Go ahead. No, Richie, go ahead.
like a direct effect is technically anything that relates to, from one variable to another.
Correct.
So
Yeah.
it's like, that's not clear that BIS is a direct effect on, like, anxiety. You know what I'm saying? Like, technically the relationship between ALS and anxiety is a direct effect. Like,
Technically, the relationship between ALS and anxiety, that is a direct effect, yeah.
so it's like you ask for conditional and direct effects. It's like, which direct effect? So I just kind of like just did without direct effects of the interaction between BIS or BIS on anxiety.
And that is totally fine. Like I said, I'm more interested in the decisions that you make than if you find that the path is non-significant and you decide that you want to trim that, because right now I'm going to hit run. We run this right now, you will see that we do not get model fit, right? And so trimming that path allows you to validate whether or not this model is even decent, right? Without trimming any paths. Oh, I must have an error in here somewhere.
Yeah, I think you forgot the C when you were defining the interaction.
The CVAS, you just put C this time.
Oh. Okay. All right, and so we have no model fit, right? Because our model is just identified; it's fully saturated. We see that BAS is not a BAS is not a significant predictor of anxiety, nor is BIS, right? We could drop that as well. Nor is our interaction. Age isn't either, but since it's a covariate, I would just leave that alone, right? So this is where I would start. I would say, like, okay, so this is a fully saturated model, and we have multiple predictors that are not statistically significant. And at this point, I would say it's fully mediated, and but just identified. In order to get model fit statistics, we trimmed non-significant paths in order to get a more parsimonious model, right? When we trim these non-significant paths, we're going to lose something. What are we going to lose?
Explanatory control, possibly.
Direct effects. We're going to lose our direct effects, right? So let's go back and let's do what I said we were going to do, which is delete that out, right? And so now that removes these paths, and we have a fully mediated model like this, right? Yeah, Anthony, go ahead.
So I know you should start with the fully saturated model. Now, shouldn't that also, like, shouldn't you make sure, I guess, that you have like theoretical support though to even define a model like that to begin with?
Yeah, so this is a great point. Everything that you do should be based on some sort of theoretical rationale, right? And so if you wanted to include these, you could say, like I included these, despite the fact that theory would suggest that this operates completely through affectability, right? Yeah, go ahead. But in order to examine the complete direct and indirect effects, we initially included paths from here all the way to the outcome variable, right? It's not necessary that you have all of those paths, especially if theory says that it operates via this mechanism, right? Yeah.
So, like when doing SEM, I remember reading this somewhere, and I wanted you to correct me if I'm wrong, but like when you get like the wall statistics and like the Lagrange multiplier or whatever, like adding, like it's easier to justify theoretically to remove like the predictors in the model than to add ones that weren't originally.
Yeah. So this is a great point. I do think Again, these are going to be opinions, right? I agree that it's easier to remove paths. If you have a path that is not significant but theoretically should be, I would say leave that path, right? Like that is poor justification. Like saying this is not significant, so we just dropped it, is poor justification. Adding a path because it is statistically significant is a little bit more dicey, right? So you can say like, hey, modification indices indicated that this path was statistically significant. And if you're going to say that, it's got to be a two-part statement, right? Also, theoretically, this makes sense because blah, 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 blah. If you just say like, this path was statistically significant according to modification indices, so we added it, I think that's a really poor rationale, right? That's a completely based on like empirical evidence and not on good theory. And yeah, I mean, you can scramble together any type of model and get it to fit good if you just trim this and trim that. That doesn't mean that it's good, right? Like it can be complete BS. And I think that actually that happens an awful lot. I would much rather see a model that fits poorly but has been like vetted through theory than a model that fits really good where people just kind of haphazardly throw a path here and there and say like that made the model fit better. So that would be, yeah, my thoughts on that. But again, a lot of this stuff, especially when you start talking about these advanced modeling issues, it winds up being kind of judgment calls that you've got to be able to justify, right? Both to yourself and to reviewers in the scientific community and so on. All right, so we removed those paths, and in doing so, we drop how many degrees of freedom? Yeah, we had 3 degrees of freedom, right? And so we're gonna, oh, you know, we are missing something here, just real quick. We're missing a statement. What are we missing? Yeah, model indirect. So let's go model indirect, and then we want to have anxiety and BIS. That's the one that we're really interested in, right? We're not really interested in BAS or anything of the sort. Like the question, the research question was, is the relationship between BIS and anxiety mediated by emotional instability, and is that relationship potentiated at high levels of BAS, right? Those were our 2 questions. So we throw this in, we hit run. That model looks like it should, right? Everything is fully mediated through ALS. Again, we're not going to have our direct effects anymore. And let's have a look at our output. Oh, we actually have 2 additional degrees of freedom here. Why is that?
Oh yeah, because these both are
Yeah.
intermittent.
Yeah.
BIS and BAS are both.
Oh, no, it's because we didn't put sex and age on anxiety, right? We didn't control for that. Let's control for that, and let's rerun this. All right, so we rerun this. There's our model fit. Is that good or bad?
Good.
Why is it good?
Because the chi-square is not significant.
Chi-square is not significant. And just FYI, this almost never occurs in real life, right? Almost always this thing is statistically significant, especially if you have latent variables. The reason that it's not here is because path analyses, path models just always fit better than latent variable SEM models. So in path models, you're more likely to get this. If you put a latent variable in there and you have a non-significant chi-square, then I would be impressed, because I don't think I've ever had that in anything that I've ever done. But anyway, yeah, that looks good. RMSEA, how we doing here? Looks really good, right? We're approaching that 0.1, but we're still below it, so I'm cool with that. CFI, TLI, how do those look? They look excellent, yeah. SRMR looks pretty solid, right? All right, and we see that we still have a statistically significant interaction, right? And if we scroll down here, we can see that we account for 7% of the variance in ALS and 36% of the variance in anxiety. It's pretty good. And our indirect effect is 0.275. That is, of course, going to be the exact same as our total effect and our total indirect effect because we don't have a path. We don't have a direct effect, right? So there's nothing to add there. What's our next step? So we've got all of this. What's the next thing that we want to do?
Look at the high and low levels of
Yeah, right? And so I would say at this point we had a statistically significant interaction, and so we probed the relationship between BIS and ALS at high and low levels of BAS, right? And so we could come and throw this up here, but I'm just going to put it like this, minus 0.8, and I'm going to go File, Save As, ARM Homework 1 HBAS. So this is at high levels of BAS, right? Now you could put this in up here and put this in your equation or whatever you wanted to do so that it signifies that it's high BAS. And if that helps you, and then by all means do it. What I'm saying is you could do this, HBAS, HBAS, change this down here to HBAS. And then change this to HBAS. Oh, yep, I see, yep. And to be perfectly honest, this, because of the way that M+ works, it will do these define statements in order. You've got to flop those around just so that it creates HBAS before it tries to create this interaction. And so we can do it this way as well. And Colleen, it sounds like this is the way that you did it. Is that correct?
Yeah.
Okay. So what was our slope before? Anybody remember?
0.275.
0.275? That was the indirect effect, I thought.
So for
0.03?
Yeah.
Okay. So our slope, if our hypothesis is correct, what should our slope be now? Higher. Should be higher, right? And I have a mistake. Unknown variable and a non-statement. Oh, yeah, I got to change these down here as well. So this should be H. This should be H. And we've now saved this as high. We hit run. There's our model. The model fit should be what? Should be exactly the same as it was before, right? That should not change. And it doesn't. And now this is what we're primarily interested in. Before it was 0.03, now it's 0.063, right? Our indirect effect should be dramatically more, and it is 0.428. It was 0.275, right? And now we have one last thing to do, and what is that one last thing? Low levels. So let's just go through. Let's change all of these. Let's change this to low and change this to low. We've already specified that this is low. Let's change this to low and change this to low. And let's go File, Save As. Let's save that as low BAS. And we hit run. And I screwed it up again. Yep.
Why aren't we defining a direct path from BIS to anxiety in the model? Like no, in the model.
Okay.
On the second line in the model.
Yeah.
From BIS to anxiety. So why aren't we defining like that direct path there?
We removed it because it was not statistically significant, and because theory dictates that everything is fully mediated through ALS, right? You could go back and add it in if you really felt compelled to, and in fact, we're gonna there is, I would say, theoretical evidence or good theory on why BIS should be linked to anxiety, irrespective of emotional instability, right? Behavioral inhibition is a kind of a multi-process type of variable for you business, you're an IO person, you're not a business person. But when you think about behavioral inhibition, right, it is linked to anxiety. It's also linked to emotional functioning and emotion regulation, right? And so I think that there's rationale to say like, hey, we should also have a direct path there. I removed it just for right now. For like, if I was writing this as a paper, I would have that path in there, and I would make an argument for why it should be in there. Right now, we're just not doing it, but we might go back and add it in. Again, it comes down to, and this is the finer point of ARM3 and of being a scientist, right? It's that in undergrad, it's very much like, how do you do a t-test? How do you do an ANOVA? And once you get to your guys' level, it's like, okay, so here's how I did this modeling. Here's how I did this analysis, and here's my rationale for why I did it this way, right? You guys are going to be independent scientists soon, and you've got to be able to not, like, those of you who have taken ARM with me before know that one of my biggest pet peeves are these stupid schematics where it's like, oh, if your data is this, this, and this, then you should follow this flow chart. And it's like, oh, ANOVA, oh, regression, oh, this, right? Like, I really can't stand these simple flow charts that tell you like, oh, I should be doing this type of analysis. I would much rather see somebody take a step back, think about their data, and say, I think I need to analyze it in this way. This makes the most sense to me, right? And then be able to support why that makes the most sense. In this case, yeah, just to throw it out there, I would include BIS, but from a theory perspective, not a data-driven perspective. So, anyway, save this, and for some reason, it is not giving me LBAS equals CBAS plus this. Oh, this. I didn't change that. Okay, let's try this again. And that did work. Our model fit should be what? Exactly the same. Yep, and it is. And we see that at high levels of BAS, the relationship between or at low levels of BAS, the relationship between emotional instability and BIS is no longer significant, right? That means our direct effect is not going to be significant, or I mean our indirect effect is not going to be significant, because an indirect effect is just the multiplication of our direct effects, right? Or our A path and B path. And if one of those is not significant, then you're not going to have a significant indirect effect. Okay, so the way that I would write this up is we first specified a fully saturated model. Consistent with our hypothesis, there was no relationship between BIS, BAS, or the interaction of BIS and BAS on anxiety. Thus, those paths were trimmed and the model was re-estimated. This new model, where BIS is the relationship between BIS and anxiety is fully mediated by ALS, showed good fit to the data, right? And then I would list the model fit at that point. Consistent with hypothesis, we also found a significant interaction between BIS and BAS predicting emotional instability, or ALS, right? Next, we probed the relationship between BIS and ALS at high and low levels of BAS. At high levels of BAS, the relationship between BIS and emotional instability was potentiated or stronger, right? And then I would list that slope, that 0.07, p is less than 0.001, right? In contrast, at low levels of BAS, the association between BIS and ALS was attenuated and no longer significant. B equals 0.01, P equals 0.09, right? Finally, we examined the conditional indirect effects between BIS and anxiety through ALS as a function of BAS. At high levels of BAS, there was a robust indirect effect between BIS and anxiety through ALS. And then I would list that indirect effect of 0.467, right? At mean levels of BAS, or when BAS was held constant at 0, the association between BIS, the indirect association between BIS and anxiety through ALS was still statistically significant, though the magnitude was reduced. And at high or at low levels of BAS, the indirect relationship between BIS and anxiety was no longer significant, right? Does that make sense? I would also throw the figure in there to show just the basic path model and a figure that shows just the slopes from BIS to ALS at high, low, and mean levels of BAS. And that is how I would have gone about doing this. I would also at some point probably throw in that the R squared for anxiety was this, whatever the R squared was, right? Make sense? Yeah.
So when you say list the direct effects, so what direct effects are you referring to?
Yeah. So if there were direct effects, and in this case there aren't because we removed them all, but we could go back in and add. If I believe once you remove all of those other things, if you put BIS in here, you will get a direct effect, a significant direct effect between BIS and anxiety. Is that right? You guys find that? Like if are we going to get model fit here? We should, right? We just lost 1 degree of freedom, so we should still get model fit. And yeah, so there's 2. It still fits, I mean, exceptionally good. BIS does predict anxiety. It's weak, right? But it does predict anxiety. So you could make a case for including that in there as long as you've got good theory. And now you will get both of these things, right? You're going to get an indirect effect and a total, and a direct effect and a total indirect effect, right? Total effect, I mean. And so if you have BIS as a direct effect, then you'll get all of these other things. If you don't, then all you have is indirect effects, and you don't have to worry about it, right? The nice thing about including BIS here, especially if it's significant, is you can say like, well, there's a total effect here, and it's attenuated, but it's still going to be there, right? Like, even though our indirect effect is no longer significant, note that our total effect still is, and that's because we have this total, this direct effect that is still statistically significant, right? If you were going to write this up in a true kind of theory type of paper, then it's probably important to include something to this effect so that you're not saying like, oh, look, if we just reduce BAS, we completely eliminate the association between BIS and anxiety, which is not true, right? Obviously, because there's a direct effect, it doesn't operate just through ALS. But for the point of homework and for data analysis, where I don't expect you guys to be enmeshed in the theory of BIS and BAS, I just want you to think through it kind of statistically more so than theoretically. So does that make sense? Yeah. What other questions do we have so far? When it comes to tables, you could feel free to put tables in there if you want. You don't have to put tables in. If you put it like this, for this, I would probably just put everything in the text, to be perfectly honest. That's just me, though. I mean, if you wanted to put tables in for indirect effects and conditional indirect effects, hey, more power to you. It's up to you. All right, let's take a break, and when we come back, we will talk about statistical power.